Hello, welcome to this video. So this problem, would be about sequence and series, in section B, of paper one, the conventional parts. Okay, so this is a word problem. Okay, so the story, about city adopts a plan to import water from another city. Okay, so about the water importing. Well, it's given that the initial volume, the volume of water imported in the first year since the start of the plan. Okay, so you keep reading the words like since the start of the plan. Okay, so keeps repeating, keeps repeating. Okay, so what is 1.5 times 10 to the power of 7 m cube? Okay, so that will be the first term. And well, very important. Okay, so you can see and in subsequent years. Okay, in subsequent years, that means in the following years. Well, every year after the first year since the start of the plan, will be using the following rate of depreciation, the rate of decay. Okay, so the volume of water imported each year, will be 10% less than the volume of water imported in the previous year. Okay, so A. Okay, so that would be the total volume. Wow, that would be very important again. The total volume. Okay, so the total volume of water imported in the first 20 years. Well, since the start of the plan. Okay, so I already told, all of you. Okay, so this kind of phrase, since the start of the plan, since the start of the plan, since the start of plan, will be keeps repeating in the question. Okay, so the problem is very specified in this case then. So part A, so find the total volume. Okay, so the total volume, or simply the required total volume. Okay, so you can see 1.5 times 10 to the power of 7 plus, that's the first year. Okay, and then in the second year, okay, so that will be 1.5 times 10 to the power of 7 times 10% less than. Okay, so that means times 0.9. Is that okay for you? Times 0.9. And then next year, so that will be 1.5 times 10 to the power of 7. And then times 0.9. Okay, so that would be just the second year. Okay, just the second year. So that would be times one more 0.9, am I correct? So that's why times 0.9 squared. Okay, so and then plus dot dot dot. Okay, so you can see for the second year, so that will be times 0.9. For the third year, so that will be times 0.9 squared. So that's why for the 20th year, so that will be 1.5 times 10 to the power of 7, and then times 0.9 to the power of not 20. Okay, so that will be to the power of 19. Okay, so that will be the last term. And then using the sum of GS formula, okay, the SN formula for geometric sequence. Okay, so that will be A times 1 minus ALU, so that will be 0.9. And will be 20, because here we have 20 terms, and then 1 minus 0.9. Okay, so and then using the calculator, and then the answer, the answer will be a bit messy. So that's why we try to correct the answer to 3 significant figures. At the same time we need to express the answer better in scientific notation. So that would be 1.32. So this number has to be between 1 and 10. Has to be between 1 and 10, cannot be 10. Between 1 to 10. So 1.32 times 10 to the power of 8 m cubed. And that's the answer for part A. Okay, so Part B. Someone claims that the total volume of water imported since the start of the plan will not exceed. Okay, so a very important phrase. Okay. Will not exceed. Okay, so that means, okay, we want to find the highest possible total volume. Okay, the ceiling, okay, the upper limit. Okay, so that's why, okay, so we can try to write like this. Okay, so first of all, again, the total volume. Okay, so equals to the first year. Just copy the above phrase. The third year. Dot, dot, dot. And then the 20 years. So to the power of 19. And then plus dot, dot, dot. Okay, so you can see, wow, to the infinity. So that's why, okay, this time, okay, because, okay, in order to find the upper limit, okay, so we are going to find, okay, the sums infinity of this GS. Okay, so we'll be using the formula, well, A over 1 minus R. Okay, so R will be 0.9. Okay, but for this time, we do not have to use the calculator because 1 minus 0.9 is 0.1, 1.5 over 0.1 over 0.1, that means times 10. So that's why here, that will be 1.5 times 10 to the power of 8 meter cube, and then less than 1.6 times 10 to the power of 8 meter cube. Okay, so that would be the suggested upper limits, okay, given by the question. Oh, so, and you can see, well, really will not exceed these upper limits. Okay, because the, one mistake. Here, okay, the total volume. Okay, so I'm afraid this one, okay, will be less than. Will be less than. Okay, because, okay, the volume, okay, cannot greater than the upper limit, right? So, and then finally, so that's why with this kind of arguments, so that's why the claim is agreed. Okay, so and the problem is done. Thank you for watching.